So, hello everyone. Welcome to lecture number 5. And today we are actually, I had a change in plan. So, what we will do is we will complete magnetism more or less today. At least we will try. So, yesterday we started with magnetic field, motion in magnetic field. So, we see three cases. Number one was what if the velocity is parallel to magnetic field? Then we have a straight line motion. What if the velocity is perpendicular to magnetic field? Then we have a circular motion. And what if the velocity is in between? Then we have a helical motion, right? So there is one just PYQ which we should do. And I saw the PYQs, it is not difficult. None of the questions is difficult. So we don't have to do very difficult questions of JEE. JEE advanced PYQs we should not do because as such, even in the CSIR NET and JEST, the questions from this topic are very straightforward, very simple. Okay. So this is the first question, which is PYQ question. And the question is something like that. An electron of kinetic energy 100 mega electron volt. So electron has a kinetic energy of 100 mega electron volt. Okay, so kinetic energy is given and it is moving in a region in a uniform magnetic field, right? And it penetrates a layer of lead. So what happens is that there is a layer of lead. Okay, so some layer of lead is there and electron penetrates through it. Electron penetrates through it. And in this process, the electron loses half of its kinetic energy. So the new kinetic energy is 50 mega electron volt. The radius of the curvature of the path has changed by what factor? So basically, how much your radius has changed? That is what you have to give an answer, right? So if you remember, the formula for radius was something like this: mv by qb. If you want to write the formula in terms of momentum, then it is m by p by qb. And if you want to write the formula in terms of kinetic energy, then it is under root 2 mk by qb. Okay. So now this question is very important. And yeah, okay. So the radius of path has changed by what factor? By how much factor the radius will change? The kinetic energy has half. Half of the kinetic energy is lost. So kinetic energy is lost by half of the amount. So what will happen? So the number one question comes here is very crucial. Actually, this is very important question. Can we use classical mechanics or do we need to use relativistic mechanics? What we can do? Can we use classical mechanics or should we do relativistic mechanics? Or is using classical mechanics will be enough? It will be okay. Okay. We should use relativistic. Why we should use relativistic? Energy is very high. High and low are always comparable. I mean, high energy, low energy is comparable. What do you mean by high energy? No, high respect to what? With respect to what you are comparing? How do you say that, okay, this is high and this is low? How do you decide that? Okay, comparable to the mass of electron. Okay, ठीक है. If you are saying so. So what is the rest mass energy of the electron? What is rest mass energy of electron? So it is 0.511 mega electron volt. And the kinetic energy in this case is 100 mega electron volt. So obviously the kinetic energy is much bigger than rest mass energy. Okay. So this is obviously there. So rest mass kinetic energy is much greater than rest mass energy. Right. So what will change in this equation? What will be the problem in this equation? Why will this equation not give me the correct answer? I mean, if we think about it, okay, let's try to do classical mechanics. So if we do use classical mechanics, then we can clearly say that radius is directly proportional to under root of kinetic energy, right? Because in classical mechanics, mass will not change, charge will not change, magnetic field will not change, radius is directly proportional to kinetic energy. So if the kinetic energy has become half, then the radius will become 1 by root 2. 1 by root 2. But here you see the answer is 0.5. Answer is 0.5. It's not 1 by root 2. So what is changing in this equation as per the you can say, what else has been changed? There is something else which has changed also. Mass. And the answer is mass. That is how just want you to make a mistake. So mass has also changed. Because you know in relativity, with speed, mass also changes. So when your kinetic energy was 100 mega electron volt, 100 mega electron volt, and when your kinetic energy was 50 mega electron volt, not only your kinetic energy changed, but your mass also changed. Okay. So what we have to do is we have to find how much mass has changed. How do you do that? How will you find out the change in mass? Okay. So what I will say is, okay, let's stop here and we will keep this question and we will come back to this question in relativity, because otherwise I have to explain entire relativity. So basically, what we want to find out here, and you can basically note this down as well. When we will do relativity, I will explain this. How to find kinetic energy. So, or you can say how to find mass from kinetic energy. Okay. So this is the idea. And we will study the equations. Basically, this is the equation which we have to study. And how is it coming? So this is something which we will study and we will come to this. Okay. And mass is given by gamma m naught c square. So if you solve these two equations, you can find out. But how these two equations came, we will talk about in relativity. Okay. But more or less, the main idea is clear here. The formula will be same, but the problem is that you also have to think about the mass. So when the kinetic energy is 50, mass is something else. When kinetic energy is 100, mass is something else. Because in relativity, mass is a function of speed. As your speed or kinetic energy changes, mass also changes. Another misconception here you should not fall into, this kinetic energy is not changing because of magnetic field. Okay, magnetic field can never change kinetic energy. This kinetic energy is changing because of this layer of lead. Because your electron hit the layer of lead, because of that the kinetic energy has changed. Okay, is it clear to all of you, right? In except for the last part which we will cover in relativity, other than that the question why you should not use the direct formula, that is clear everyone. But you have also have to take care of mass. And why mass? Because you see the rest mass energy of electron is only 0.5, but the kinetic energy given is 100. So this is very, very greater. That is why you should use relativity. Okay. Okay. Then in this context, we also should study one very important thing, which was known as uh, velocity. Okay, one person asked a very good question, that how do we need to check for relativity in every case? Yes, whenever your energies are given, especially if you see the energies are given in mega electron volt, or the particle is electron. Usually for proton, this problem will not be there. For proton and other masses, this problem will not be there. But since electron is a very light particle, very, very light particle, so this problem will always come. So whenever you see electron in your questions, or whenever you see the energies in the mega electron volt, then you should definitely look, okay, if your energy is much greater than mass or not. If it is not much greater than mass, then it is okay. But if it is much greater than mass, then you should definitely use relativity. Once we will do relativity, you will be more comfortable with this. Okay. Then you will, by looking at the question, you will see, okay, here I have to use relativity. Okay. Now, one very important thing is known as velocity selector. So velocity selector is a very practical device. I mean, it's a very, very practical device, and it's a practical device for all the nuclear physicists. All the nuclear physicists. Okay. So what does nuclear physicist do? Is there any issue with the voice and video? Anyone? We can fix that. Yeah. Any problem? Anyone else facing? Okay. No, no, yes, no. Okay. Okay. ठीक है. So anytime anyone, most of you start facing a problem, please let me know. Okay. So velocity selector is a very practical device. So what does it do? So let's say I am doing some nuclear reaction. I'm doing some nuclear reaction. So let's take an example. So what is an example? So let's say I have a nucleus, and now I want alpha particle come and hit the nucleus with a very high speed. So I want nucleus is there, right? And I want alpha particle to come and hit with a very high speed. Okay, there is a problem, right? Too much hanging or problem is there. Okay? Lagging is happening. There is a latency issue today. Yeah, okay. Latency is coming. Okay, yeah. Let me pause for a while and let's see. Let's see. So what I want in this case, forget about the video. If there is any problem in the audio, then say, otherwise don't look at me. Mainly focus on the screen, right? So I want is that alpha particle comes at a very high speed and hits the nucleus. Now alpha particle, I want it at a very fixed speed. So let's say I want okay, this alpha particle comes at a speed of 2.2 into 10 ki power 6 meters per second. And I want only this speed. I don't want alpha particle to come at a speed more than this or less than this. But the problem is that when you are producing alpha particles, so let's say you produce alpha particles, some alpha particles will have more speed, some alpha particles will have less speed. How do you make sure that only alpha particles with this speed comes and hit the nucleus? Because whenever you take a sample, some particles have much higher speed, some particles have much lower speed. So particles of different speeds are there in the sample. Out of that sample, you want to make sure only those alpha particles come which have a speed of 2.2 into 10 to the power 6 meters per second. So for that, we use velocity selector. Okay. So how is velocity selector made? Velocity selector is made up of crossed electric field and magnetic field. Crossed electric field and magnetic field. Crossed means perpendicular. So let's first understand magnetic field and then we will understand electric field. So let's say I put a magnetic field. So this is my magnetic field. Magnetic field cross means going inside the plane. It is entering the plane. So let me write magnetic field here. Magnetic field is B. Entering the plane means minus K cap. Okay. And now your alpha particle is coming. Okay. Or any charge particle is coming. Let's say Q charge particle is coming and it has a velocity of V. Now you can clearly see the velocity is in I cap. So V I cap. So I find the force now. So force will be equals to Q V cross B. Right. This is a magnetic force. And if you find out I cross K is minus J and minus minus will cancel. So you will get QVB into J cap. It means the force acting on it is in upward direction. Is in upward direction. It means if you have a charges coming, then because of the magnetic force, the charge will go up. It will go like this. I don't want this because my nucleus is here. I want that this charge particle comes and hit here. Hit the nucleus. Okay, hit the nucleus. So what I will do is I will apply electric field also. So what I will do is I will apply electric field like this. So this is now I am applying an electric field. Okay. So how do you apply electric field? You put one positively charged plate here and you put one negatively charged plate here. Electric field is always from positive charge plate to negative charge plate. So this is you have put electric field. So now the charge will also experience electric force. So how much will be electric force? It will be QE. Okay, and it will be Q. Electric field is in negative J direction, so minus J, right? So magnetic force is acting upward, electric force is acting downward. Electrostatic force is acting downward, magnetic force is acting upward. If I use electric field and magnetic field in a very particular amount, basically electric field I am applying, magnetic field I am applying, so their magnitude is in my hands. So if I make sure that electric field and magnetic field are applied in such a way that electric force का magnitude and magnetic force का magnitude are equal. So electric force is acting downward, magnetic force is acting upward. If I make sure that electric field and magnetic field are like that their magnitude is equal, then no net force will act, zero net force will act, and this charge particle will hit the nucleus. Because no net force, so it will not go up. No net electric force, so it will not go down. It will go straight forward and hit the nucleus. Right? So electric force is QE, magnetic force का magnitude is QE, sorry, and magnetic force का magnitude is QVB. Q and Q cancels, so velocity comes out to be E by B. E by B. So all the particles which have this velocity, will go undeflected. So all those particles which have this velocity, which is E by B, I can choose E and B. So let's say I want velocity to be 2.2 into 10 to the power 6. So what I will do is I will use electric field, which is, let's say, 4.4 into 10 to the power 6, and I will use magnetic field, which is 2. So E by B will be 2.2 into 10 to the power 6. Right. So whatever velocity I want, I will choose my electric field and magnetic field in such a way that if you do E by B, you get that velocity. So E and B are in my hands. So all the particles which have this velocity will go undeflected. But if your velocity is more, then you will deflect downwards. If your velocity is more, and if your velocity, sorry, you will deflect upwards. And if your velocity is less, so this is velocity more than E by B. This is velocity less than E by B. And this is velocity equals to E by B. So only one particular velocity is allowed, which will go straight and hit the nucleus. Only one particular velocity, V equals to E by B. If your velocity is more, velocity more means magnetic force is more. Right? More velocity means more magnetic field. That is why you see the magnetic force will dominate and your particle will move up and it will not hit the nucleus. But if the velocity is less, then the magnetic force will be less and hence it will move down and it will not hit the nucleus. Only one kind of velocity will hit the nucleus, that is equals to V equals to E by B. That's all, nothing else. And that is how we achieve velocity selector. So now only one particular velocity is coming and hitting the nucleus, and that is V equals to E by B. No other velocity is hitting the nucleus. Okay? Someone can ask you, if velocity is more, then magnetic field force will dominate and it will go in the direction of magnetic force. And if velocity is less, then magnetic force will be less and it will go opposite to the magnetic force. Okay, so that is what will, because if the magnetic force is less, then electric force will dominate and it will go in the direction of electric force. So that is how we design a velocity selector. So few important things. First you need is a crossed magnetic field and electric field. Why crossed? You can clearly see that electric field and magnetic field are perpendicular to each other. So you see your electric field is in J direction, minus J direction, but your magnetic field is in minus K direction. J and K are perpendicular to each other. So you are applying crossed electric field and magnetic field, and only one velocity is allowed to move undeflected. All other velocity particles will deflect. So when you take a sample, so only one particular velocity will move undeflected and hit the nucleus, and all other velocities will either go up or down. Yes, is it clear to all of you? Any doubt in this topic, please? If you want me to repeat, let me know. Yes, please. Next, let's do some problems on this. Okay. So yeah, this is a problem. Yes, yeah. If the particle is moving in y, then the directions of electric field and magnetic field will also change, obviously. Okay, so that this is a kind of question you are asking. So the question is, a positively charged particle is placed at the origin with zero initial velocity. Okay, so origin पे placed है and it has no initial velocity. In the presence of constant electric field and constant magnetic field along positive z and positive x direction. Okay, so electric field is along positive z direction and magnetic field is along positive x direction. Okay, so this is what is happening. Perfect. At the large times, the overall motion of the particle is a drift along, a drift along. So what will happen because of this? What is going to happen because of this? That is a main idea here. Okay, so let's choose. First of all, let's choose how. Let's choose the coordinate axis. So let me draw coordinate axis in a good way. So you can see all the three axes. Okay, so this is x, this is y, this is z. Okay, or let's say z, x, y. This is okay. X, z, and y. So the magnetic field is along this direction. This is how your magnetic field is there. Electric field is in this direction. Okay, and your charge particle is placed here. This is your charge particle. What will happen? What will happen? So initially at time 0, velocity is 0. Velocity is 0. So magnetic field force is 0. Magnetic force is 0. No magnetic force is acting. No magnetic force is acting. Only electric force is acting. And electric force is given by QE. If Q is positive, then electric force and electric field are in the same direction. But if Q is negative, then force and electric field will be in the opposite direction because negative sign will come. So if charge is positive, electric force and electric field are in the same direction. But if the charge is negative, electric force and electric field will be in the opposite direction. In this case, the charge is positive, so electric force and electric field will be in the same direction. Okay? So what will happen is your charge particle will start moving in this direction. Right? Because initially there was no magnetic force, only electrical force. Why there was no magnetic force? Because velocity initially was 0. Initial velocity was 0. Now what will happen is that your particle has started moving along z-axis. So after some time t, at time t, little bit after some time t, now your particle has a velocity along z-axis. Now your particle has a velocity along z-axis. So now magnetic force and electric force both will act. So what will be the magnetic force? Q V cross B. Okay, so we call it z-axis. Okay, V cross B. So Q is Q, V is V, B is V, B is B. Okay, what is V cross B? So Z cross X. Z cross X will be minus Y. Minus Y. Okay, so basically this is minus Y. This is minus Y, but because this is plus Y, this is minus Y, right? So now the magnetic force will also act. Electric force will keep acting, but magnetic force will also start acting. Electric force तो लगती जा रही है ना, electric force will always be acting, which is QE. So electric force is not changing. Electric force will always keep acting along Z axis. So electric force is fixed. Electric force will always keep on acting along Z axis. Okay. But now the magnetic force also starts to act, and it acts along minus Z axis like this. Right. So this is what is happening. So this is what is happening. So after some now then it will move in a circle, and then it will basically speed will keep on increasing because of Z axis, and the motion is circular. So now let's try to answer. At larger times, the overall motion of the particle, we just have to predict one thing. Overall motion of the particle is a drift. Now you have to tell me in which direction the particle is drifting, moving forward. Can you tell me in which direction the particle is drifting? That's all. Nothing. You don't have to be looking at the overall motion. Just let me know in which direction it is drifting. Drift. Moving forward. And tell me why, because of which force it is drifting. Magnetic force or electric force? Because of whom it is drifting? Yeah. Answer. Try to answer. Positive Z direction. Okay. Okay. What else? Positive Z. Because of E, it is drifting along positive Z. Okay. Due to electric field in the Z directions. Okay. The question is not that easy. It's not that straightforward actually. Every one of you are getting uh, you are saying that it is along that, but it's not easy, that easy. Z cross X is no, velocity is Z directions. Okay, ठीक है. Z cross X is plus Z. Yeah, sorry. So here I made a mistake. It is plus Y axis. ठीक है. So actually the magnetic force is like this. This is how your magnetic force will be. ठीक है. This is how your magnetic force will be. So what is going to happen after some time? What is going to happen? What is going to happen? So your particle will move like this. It's like this, right? What do you say? Because electric force is trying to move it in Z direction, magnetic force is trying to move it in Y direction. The net force, if you see at this time, will be like this. This will be the net force. So now you have to choose a very simple thing, like here. At the larger times, time make the time larger. Make the time large. So this is a point where you have to think here. Large time. The time has been very large. Now what will happen? So the time is large. Okay. तो क्या हो रहा है? Let me show you now. Electric force की वजह से speed is increasing. Speed is increasing. क्यों? क्योंकि initially the speed was 0, but now the electric force की वजह से क्या हुआ? Electric force is acting along Z axis. Electric force change नहीं हो रही. Electric force is not changing. Electric force keeps on acting in the same direction. So this is not changing in magnitude. This is not changing in direction. Neither changing in magnitude, neither changing in direction. So let's say this is 10 Newton. So it will remain 10 Newton forever. And it will always keep on acting along the Z direction. But because since the force is acting on it, the speed will increase, because electric field can change kinetic energy. Magnetic force cannot change kinetic energy, but electric force can change kinetic energy. That is why the speed of the particle keep on increasing. As the speed of the particle keep on increasing, the magnetic force also keep on increasing. और increase होता ही जा रहा है. It will keep on increasing because speed is increasing, so magnetic force will also increase. And it keeps on increasing, keeps on increasing, keeps on increasing, keeps on increasing. After a very large amount of time, the magnetic force will become very, very larger than electric force, because electric force is not changing. Electric force remains fixed. So think like this: electric force remains fixed, but because of the electric force, speed is increasing. Speed is increasing. But since speed is increasing, the magnetic force keeps on increasing, 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 so much that after a very large amount of time, magnetic force will so much dominate. So the particle will basically will have the same direction. So basically it will be like this. So the motion is like this. It will ultimately, it will be mainly because of the magnetic force. And in which direction magnetic force is acting? Answer is positive y direction. Magnetic force is acting in the positive y direction. So at a very large amount of time, after a very large amount of time, the force which will dominate is magnetic force. It is not actually electric force. Electric force will remain very small. It will be very small fraction of a magnetic force. Okay, so that is what is going to happen. Yeah. इलेक्ट्रिक फोर्स, यार ये तो बड़ी गलत बात है. देखिए क्या है ना, ये सी आप क्या पूछ रहे हैं मेरे से, देखिए. ठीक है, ये देखिए. सो दिस इज योर चार्ज पार्टिकल and this is your electric force, electric field. Because of the electric field, the force will be QE. So whenever there is a force, there is an acceleration, right? QE by m. So the because of the acceleration, the speed of the particle will keep on increasing. So इसका जो speed है वो increase होता जाएगा, होता जाएगा, होता जाएगा. Because of the electric force. Electric force की वजह से the speed will keep on increasing. Yes, magnetic force की वजह से speed does not change. Speed do not change because of magnetic force. But because of electric force, even if the electric force is there, electric force को change होने की जरूरत नहीं है. Even if the electric force is there, let's say it is 10 Newton and it remains 10 Newton, right? The speed keeps on increasing. It is like a earth gravity. So earth gravity is fixed. But as we keep on falling, keep on falling, keep on falling, our speed keeps on increasing. The gravity is not changing. Gravity is fixed. So here electric field is like that. So because of the electric field, the speed of the particle keeps on increasing. But the electric force itself is not changing. Electric force itself is fixed because it is Q into E. So neither Q is changing, neither E is changing. Perfect. So number one idea is, so what is the number one idea in this question? Initially the particle was at zero. Initially the particle was at zero. So electric force is acting in this direction, and this electric force is fixed. Electric force is fixed. Force is not changing. Electric force is not changing. Because of that force, the speed of the particle is changing. So initially particle had no speed, but now it has some speed. After some time, it will have even more speed. After some time, it will have even more speed. And speed in which direction? Speed in z direction. Its speed will keep on increasing. Because of which force? Electric force. If the speed keeps on increasing, magnetic force will also keep on increasing. So magnetic force keeps on increasing, 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 increasing. And then ultimately there is a point when magnetic force will become so large, right? Magnetic force will be so large then it will dominate. And magnetic force is acting in which direction? It is acting in y direction. So ultimately what will happen is particle started like this, it goes like this, and ultimately it will like this. It will be like this. So this is going to be the trajectory of the particle. So ultimately the magnetic force will be the only dominating force. Okay. So the net drift is along positive y. It is not along positive z, because ultimately the particle will not be like this. Ultimately the particle will be like this. Okay, that is the main conceptual idea here. Yes, is it clear to all of you? किसी को doubt है तो please go ahead. See, very conceptual question. It's not a very simple question. Conceptual. Okay. So what are the rules we learned in this question? So rule is electric force, electric force. Okay. And then electric force does not change with time, does not change with speed. It does not change with speed. Or the speed change होने से this force does not change, and it can change the speed of particle. Because of the electric force, the particle speed can change. Okay. So Kanak, you're right. Kanak is saying that with time the direction of magnetic force will change. Okay, I agree with you. It will change, but we have to see what it trying to do. It will try to do the rotation. It will try to do the rotation, and rotation it will try to do in the, because initially if the force was like this, so it was trying to do the rotation. So basically magnetic force will try to bring the particle in a upward direction, upward direction. So that is our idea here. Okay, that is our idea, nothing else. Okay, so we don't want to find the force at each direction. Obviously that will change, obviously that will change, but you have to think, once the velocity become like this, once the velocity become like this, then you can clearly see that um, uh, again you, the ultimate idea is to bring it in the upward direction, nothing else. That is a point. Yeah, so ultimately it will become E by B. Yeah, that can happen. Okay. So one last time I'm giving you the basic idea. So very basic idea is the particle was initially at rest. Don't think too much about it. Particle was initially at rest. Then because of the electric force, it started moving in this direction. Electric force does not change. Electric force is simply equals to QE. So electric force will not change. But because of the electric force, because whenever the force acts on a particle, the speed of the particle changes. So the speed of the particle will change. It will change, it will change. It will keep on increasing. So initially what was happened was electric force was more, magnetic force was less. Magnetic force was even zero. But because of the electric force, the particle obtained the speed, and this speed is increasing. As the speed is increasing, the magnetic field force will also starts to increase. And after a long time, magnetic force will dominate, and magnetic force is acting in a positive y direction. Okay. So ultimately particle will be in the positive y direction. Drifting, it's drifting. I'm not saying that it will, it is basically the purpose is to bring it in the positive y direction, means upar leke jana is a purpose. Okay. Okay, now this is another question. This is simple, this is simple mathematics, not that difficult, I think so. Let's read it, but I think so this is simple. Okay. So previous question was from CSIR net, and this question is also from CSIR net. Okay. An electron enters a region of uniform electric and magnetic field. So there is a uniform electric and magnetic field. Its velocity E naught and B naught are mutually perpendicular to each other. So it is like a velocity selector, right? Mutually perpendicular electric field and magnetic field are there. So it is like a velocity selector. Initially, E naught is so adjusted that electron suffers no deflection. No deflection, you see. So basically they are saying initially particle is not experiencing any deflection. Right. So if particle is not experiencing any deflection, so then you know V equals to E by B. So this is a condition for no deflection. In the velocity selector, we learned that magnetic force and electric force will become equal. So magnetic force and electric force will become equal, and they are in opposite directions. So no deflection. So velocity is equals to E naught by B naught. Okay. Now what they're doing is they're saying E naught is then switched off. We now switch off the E naught. So now only magnetic force is there. An electron moves in a circular path of radius r. Okay. So what is the speed of the electron and its charge to mass ratio? What is the speed of the electron? Can you tell me what is the speed of the electron? First of all, it's clearly written on your screen. It is E naught by B naught. So either option number 3 will be correct or option number 4 will be correct. Now you need is charge to mass ratio. So what is the formula for radius? Radius का formula होता है mv by qb. ठीक है. So what you need charge to mass ratio which is q by m, v by br, right? V by br, and you can put the value of v is E naught by b naught square r. So charge to mass ratio will be E naught by b naught square r. Perfect. So which option is this? C. Clear? Nothing difficult here. This was easy. So initially both were there. So electric field and magnetic field both were there. So you were in velocity selector case. It was moving undeflected. So obviously the velocity was E naught by B naught. Now you switch off the electric field. So once you switch off the electric field, you go to the previous lecture, yesterday's lecture, because now only the magnetic field is there. And if your magnetic field is there, then you can have three cases: straight line, circular, or helic. They have given you that it's a circular motion. So it's a case number 2. Only magnetic field is there, and it's case number 2, circular motion. Circular motion has a radius mv by qb. Radius is already given to you, and you have to give an answer in terms of radius. And they are asking you what is the charge to mass ratio. So q by m will be v by br. You just put the value of b, which is E naught by b square r, which is option number C. सबको समझ आया? This was 5 marks question in last CSIR net. तो जो पिछला CSIR net हुआ उसमें 5 marks question. जी, any doubt? That in the class recording. Why do we do not talk about magnetic potential energy? You must have seen gravitational potential energy, you must have seen electrostatic potential energy, but you must have never seen magnetic potential energy. At least in your classes, in the advanced classes of electromagnetism, they talk about it. Okay, the concept of potential energy comes for conservative forces. कैसे? So it basically means that this is ground. ठीक है. So ground के ऊपर potential energy क्या है? 0. And at some height potential energy क्या है? mgh. ठीक है. Okay. But if I go from here to here, what is the amount of work done I have to do? So I have to do u2 minus u1, which is mgh. So you see, I do not have to use forces or anything other than that. Only by the knowledge of potential energy, I can answer this question. Okay, how much energy I need if I want my particle to go from here to here? Minimum energy. How much minimum energy I need if I want my particle to go from here to here? Okay, so it is mgh. And if you even calculate that using the forces, so you see force into displacement. What is the magnetic force? Magnetic force is m, and what is this displacement? H. So that also comes out to be same. So either you use force or either you use energy, both will give you same answer. And that is possible only if the force is conservative. Because if the force is conservative, then you know del cross F is 0, and you can write your F as gradient of potential. And this you can write only if your force is conservative. If your force is not conservative, you cannot write your force as gradient of some potential. So basically you cannot define potential. Potential is a defined thing only for conservative forces. Potential is a other way of doing things. Potential is not a new thing. Potential is a other way of doing things. So rather than dealing with the force, which is a vector thing, you can deal with the potential, which is scalar. And obviously working with scalar is easy. So you can write your force in terms of potential only if your force is conservative. If your force is not conservative, then you cannot do. And we studied yesterday that magnetic force is not conservative force. That is why we cannot not write magnetic force as some sort of gradient of potential. That is why we do not define scalar potential in case of, we do not define scalar potential in case of magnetism, but we do define vector potential. Vector potential, which is A vector. Can anyone tell me what is the definition of A vector? What is the relation between A vector and B vector? So B is equals to, oh, उल्टा तो नहीं है. B is equals to del cross A, right? Yeah. Okay. So we define that. So B vector is equals to del cross A. But this is not actually, we are not simplifying our problem. This does not simplify us, because B was also a vector, A was also a vector. So you deal with B or you deal with A, both are equally difficult. That is why in magnetism, we do not deal with scalar potentials. Why we cannot deal with scalar potential? Because magnetic force is not a conservative force. That is why you see that. Okay. I hope this doubt is clear. Yeah. Whoever asked this question, is it clear, right? Who asked that? Jay Shankar, is it clear? Then we do define potential energy of magnetic dipole. See, okay, that is also good question. So he asked that, but when we study magnetic dipoles, okay, this is one dipole, this is another dipole. What is the potential energy between them? What is the so that is actually not a potential energy, that is an interaction energy. That is an interaction energy. So we do define interaction energy of two. Obviously, when the two magnets are close to each other, they are exerting force on each other. And then we can define interaction energy. What is interaction energy? Basically, what is the basic idea of interaction? What is energy? Energy is ability to do work. The basic definition of class 11th or class 6th, 7th, 10th, whatever. Energy is an ability to do work. So let's say I have two magnets, north, south, north, south, and I nail them. Nail them means I take a nail and I put it there. So they cannot move. They cannot move. Okay? Or I hold them. You nail them or hold them, whatever you hold them. Now what is happening? This north is repelling them and this north is repelling him. Both are repelling each other. Both are repelling each other. It means both wants to fly away. Both wants to fly away. But they are not able to fly away because I'm holding them. But let's say I stop holding them. They will fly away. It means before I was holding them, they had an ability to fly away. They had an ability to do work. Because I was holding them, so they were not flying away. But it means they have a stored ability, stored energy, stored ability to fly away. That is why we say that they have some stored energy. And whenever we say that we stored energy, we associate it with the potential energy. Okay? But it is not a general potential energy we are talking about. So it's basically an interaction energy. This energy is coming because of the interaction between them. This energy is not coming because of third person. This is because of each other. They have an interaction energy. Interaction energy means because of each other, they have a stored ability to fly away. Whenever you have an ability to do work, it means you have energy. Now clear? Is it clear now? Yeah, done. Perfect.